All right, so let's go back to our composite pattern. Okay, every time when you start a new study a new design pattern, you have to know what the problem is we're trying to solve. Okay, we talked a little bit about the motivating problem last time, especially when you got basic and also recursive components for your system. Okay, I'll get to the design in just a moment. Okay, we got basically this is kind of the diagram we want to model in the design, right? So this can be basically anything that you can model as a general tree. Doesn't have to be binary tree, any tree. The tree structure. So now I want you to pay attention to the following. Okay, you can think about maybe every components over here. For example, chassis, cabinets, power supply, DVD, CD-ROM, and hard drive and card. Every one of them will somehow be turned into a class eventually. Okay, and now every class over there is going to support the feature. Let's say for the price. We want to figure out what's the price for this particular cabinet. Okay? The cabinet itself contains 2 chassis. Each chassis contains a card, contains a hard drive, and also each one, another one contains a DVD, CD-ROM. We want to aggregate the price together. That's the problem we're trying to solve. We're going to, as usual, I'm going to show you some not so good design, first of all. And we're going to criticize on that to see why it wouldn't be a good design before we turn to the composite pattern. I think that'll be a better thing for us to think about, right? You always want to think about the design. Let me mention one more thing before we get to the first one. I want you to, for example, let's say cabinets versus power supply, okay? These two. Let's say in the cabinet class, we have a feature called price. And also in the case of power supply, we also have a class called we also got a feature called price. However, there's one thing you want to pay attention to. The power supply and the cabinets, they are fundamentally different in the following sense. The cabinets is a recursive component, which means you might have descendants. You might have subcomponents under which. On the other hand, power supply is more like the base case for you, right? You shouldn't be able to store anything further under power supply. Okay? That's a critical difference between the two. Okay? Keep that in mind if you want to judge to see if a particular design can solve this problem here. So what I would like to do, I would like to go directly, sorry, not here. I want to go directly to the first design. Okay? Let me just give that to you quick. Okay, we went through this last time. Okay? We talked about multiple inheritance just to the extent that will help you understand the composite pattern eventually. And also we talk about rename, right? There's something if you want to do for your projects, feel free to use rename. Okay, so now I will go to the composite pattern over here. So this slide here, I'll go over this in the last stage because this one pretty much summarizes what's going to happen when polymorphism, dynamic binding, everything works together. It wouldn't make much sense right now. I'll rather go over this slide at the end. Okay, let's now skip it just for the moment. Okay. What I would like to do is go directly to the design. Okay, this is the first attempt. Okay, and to really okay, let me just switch the iPad. The same diagram. Okay, let me just explain very briefly what the first design is. Okay, you can think about it and let me know whether or not you believe it's a good design, a good solution to the problem. Let's say for the equipments. You can see that. Let me highlight. So we have, let's say, the client is the main. Okay, and then the client is using an equipment. That's why we got a client-supply relationship with E. You can see that we are trying to introduce you to the design rather than coding directly, right? It's really important for you to imagine what's going to happen if you want to implement it either in Java or IFO or other language. So the main program is trying to declare some clients, some supplier, E, and then equipments. You can see this actually star. Okay, it's a bit not so well displayed. Okay, equipment is simply deferred, which means you cannot create instances directly out of the equipments. Okay. And then we got subclasses like a card, we got disk drive, and also we got another class over here called composite equipments. They seem to be the recursive part, right, for the system. Right? Under composite equipments over here, we have cabinets, we have chassis, we also got bus. Okay, each bus can connect to a different component. That's why it's also composite. And now let me just say a little bit more things. You can see this particular equipment over here. We have the following features. Every one of them has a price. Okay? Every one of them has the add feature, which you can add more equipments under which. Okay? And also, you have the children feature as well. So if you want to, let's say, for example, let me go back to the diagram quickly. Okay? If I go back to the diagram over here, you can see that over here in this particular case, sorry, let me just go back quickly. You can see for this cabinet over here, let's say cabinets is actually over here, right? Cabinets here, and then cabinets, also because of the children over here, we also have a client supply, which means for the composite equipments, we have the children, which means a list of equipments, right? So now for the cabinets, you can see it has child number one, which is a chassis. Child number two, which is another chassis. Child number three is a power supply, right? So the children is simply just a list of equipments. Okay, so that would be what I want to say about the first design. Okay, now I want you to look at this design for a moment and then tell me how you think of it. If you think it is good, you can let me know. If you don't think that's appropriate, why not? Okay. I can give you a little bit hints. Okay, every time you're trying to talk about a particular design, think a little bit about how you're going to use the design. Okay, I gave you a little bit hints over here. Let me just go over the hints before you say anything. Yeah. Okay. Over here, you can see I have basically some variables over here. I got CH, CRD, and D of type chassis, car, and disk. And somehow I'm trying to create new objects over here. I'm also trying to add them. For example, for chassis, I can add a car into it. For the disk, I can also add it under the chassis, right? Which means a single chassis can hold different things. Okay. That's kind of the hints I'll give to you, which may not complete, of course. Any comments? Yes?
Then does it mean that, I don't know, say you have 1,000 equipments, then you have to do 1,000 creates?
Okay, basically you're saying the number of equipments you have is going to correspond to how many creation features you're going to have. I don't think there's any way around. Pretty much like if you're doing Java. If you want to have so many objects, you got to create that so many times. There's no way around. Yeah. It's hard to say a single create, it can give you 1,000 objects, right? That'll be scary too, right? Okay. So that would not be the issue. Okay. Yes. For example?
We can add something to this
Mm. Okay, can everybody see that? You know what? You see, there's something you really want to get familiar with before the exam. In the exam, we don't necessarily give you the code directly because after all, this course is about design. We might just give you the design diagram over here and ask you what can be wrong when what can go wrong for this particular design. That's exactly right. Okay, let me just illustrate very quickly. You can see that what's really wrong is we are basically mixing two concepts together. Price is basically the property for each equipment, okay? So this is the common property for every equipment, either recursive or basic. On the other hand, these stuff, add and children, they are not exactly to do with every type of equipment. They're only for recursive ones. More precisely, they're more for building the tree related, right? So now let's go along with that thought. Because the children, for example, is actually let's say the add. The add feature is actually available at this level over here, which is a common ancestor for basic and also composite equipments. For this part, it is okay. That's exactly what is wrote. So that means you can say chassis, which is over here. You can say chassis.add. That's not a problem. That's okay. What I didn't write was as follows. If I got something like this, let's say I got card over here, which is over here, right? If I say CRD dot add, and then I want to add a let's say I want to add a disk inside a card. Well, conceptually, it doesn't make any sense, right? How can you add a disk inside a car? That's not possible, right? However, would this design allow this? That's the question. You would, because think about it. The static type for this particular card is card. And then card is over here, which inherits the add feature from the common ancestor equipments. So this is okay. And it was simply adding any equipments over here, right? What we learned about polymorphism before. So that means this is actually allowed by your design, but it simply doesn't make sense. Okay? So this is allowed in the design, but doesn't make sense. Okay, how can you add a disk into a card? So the main issue over here is we have a mix of concept. So we're breaking cohesion, right? Remember we talked about cohesion before. Okay, Hesion. So now can somebody tell me at least, when was the last time I mentioned about cohesion? Which pattern did we talk about cohesion? Was it iterator?
I think singleton.
Singleton, yes, in what sense?
Having a separate class for the access.
Exactly, yes. For the singleton, we say that you want to have separation of concern. You have one class just for the data, another class for the access to the data. So here, similar. We want to also have cohesion in the sense that every feature in a single class should be related under the same theme. But now we're mixing two things over here. First thing is about the common property, which is price. The second thing that's being mixed is the tree-related properties, like add and children. We don't want to mix them. Okay? So a much better design would be to separate these things over here into another class, possibly, and then keep this as a common property for all the equipments. So once we separate out, for example, add and children, for example, I'm just sketching quickly. Okay? We're going to see the proper design diagram in just a moment. Once I separate these two features out into a new class over here, so now, who should be the descendants for this class? Equipments? Are you sure? Okay, let's say, okay, let me make my question more clear. How about that? Okay, so let's say over here, let's say I'm creating a new class over here, which is, let's not worry about the name for the class. I'm basically separating out these two features into this new class over here, which will support the tree-related operations, add and children. So now my question is, should this class stand alone? Or should there be some descendants for this class? Think about it. Composite requirements should be its ancestor or descendants. Yes. So what you're suggesting is we're going to have basically something like this. So that means for basic equipments like a card, they only have one ancestor, which is equipments, which will only support a common property. On the other hand, for the composite equipments, it's both going to support both the common property, which is price, and also is going to support the tree-related operations. So that's why multiple inheritance could be useful over here. Are we okay with this? It's a very informal sketch. Okay. What we're learning from this diagram over here for the first design, you want to be able to judge by yourself just by looking at the design diagram. You want to imagine if at the runtime, anything that will compile can actually cause something that will go wrong. For example, in this case, it will go wrong if you try to add a disk into a card. That shouldn't be allowed, but it was allowed. Guys, any questions? Okay, yes?
Why have it be a separate class and not have this new one be a child of equipment and then have composite equipment be the child?
It's a very good question. Basically, what you're asking was, okay, basically you're asking the following, okay? Very good. The short answer to that is reusability. I'll illustrate that. Very good question, absolutely. Basically, let me just add a new page quickly, and then basically you're asking this. Let me draw that very quickly. So remember, we have the class called equipments over here. Okay, that one's deferred. Let me just make one descendant over here, which is card. You're basically asking, rather than creating this particular class to be separate from composite equipments, why don't we simply merge these two features inside? Let me draw it quickly, okay? So now I'm going to do basically this one here. Let's say it's composite equipments. And then I'm going to get add. Also, I'm going to get children. Okay, under which, let's have another class. Let's say chassis. How about that? Okay, very good. I tell you what, this is going to work. I'm not saying it's not going to work. It's just not a very good design. Okay, let's think about extensibility. Okay, let's say we want, well, pattern is really called pattern because it can solve similar problem. Let's say I got this problem aside for manufacturing equipments. Let's say I want to get another solution for, let's say, furniture, for example, right? If I want to have, well, you can also see for furniture, let me just give you one example here. Following this design, let's say, how can I create another, let's say, another cluster for furniture? Okay, let me just draw it to represent precisely what I meant. Let's say this is over here, the cluster. Okay, I'm just going to put it inside a box. Let's say this is going to be the cluster over here called equipment, let's say manufacturing. Okay, that's a manufacturing cluster. Let's say I want to have another cluster over here for furniture. Okay, I'm going to put it here. Okay, another cluster. Now, let me sketch the idea according to what you just mentioned. Okay, so now if I simply say I have one top class over here, which is called furniture, and then let's say over here, a base case could be, let's say, a chair, for example, right? Nothing can be contained under the chair. And then under which, over here, I'm simply just going to have, let's say, composite furniture. Okay? Composite furniture. And then under which, I'm going to have some composite furniture, let's say bookshelf, for example. Bookshelf can contain other things, right? Let's say shelf. Okay, and also over here, I'm going to have add. Let me be more precise. The add over here, what would be the parameter type for this case? What should I add in general? Equipment, right? Thank you. Okay, it's really important. Okay, let me just add it down. Okay, equipment, I'll say E. And what about the add over here? Furniture. Okay, I would say, let's say E also, it's going to be furniture. I'll say F. Okay, E versus F, different types. And also children. And similarly, for the children in this case, it's going to be list of equipments. In the children over here, going to be list of furniture. Does the design smell? Sorry, I'm saying a little bit rude. Okay, do we violate single choice principle?
Yes.
How?
Because every time you have a different structure, you have to add.
Yeah, basically you can see that. That's why I use a different color. Look at the pink class between the two clusters. They are essentially the same. The only difference is in the left-hand side, over here, in the left-hand side, you can see the add feature is going to take just equipments. But what about the body of the add? It's going to be the same. Just extend whatever structure you have. On the other hand, on the right-hand side, over here, it's going to be furniture. Just the type is being different. So now, how can we improve it to a better design? Which means we may want to factor out this particular same operation, the pattern, into something. But how do we handle different types? That's a problem. Yeah, absolutely. That's exactly the scenario to use generics. Exactly. Okay? So now, any suggestion? How do we fix it? Okay, conceptually. I really like the question. That moves so smoothly to the actual composite pattern, so smoothly. What I would suggest is this. Let's say outside these two clusters, I'm just going to have a general composite class. As you suggested, let's make it generic. I'll simply say T, okay? Or it can be G, whatever. And then over here is going to be add. Add is going to be adding something to be of type T. Agree? It's completely generic, which means T can be instantiated into furniture, to equipment, to whatever. Right? Can be reused for many times. And also the children over here is also going to be a list of T. So now what do we do? Do we need any inheritance? Okay, so that means we don't actually put add over here. We don't put the children over here anymore. They are factored out. So now, to complete the picture, how many inheritance links should I draw? 2, right? Yeah, 1 for each. Yes, exactly. So now I'm going to draw one. Composite equipment is going to use this particular one. And also composite furniture, okay, is going to use this one here. That's going to be a better design. That is why we don't actually put the add and children directly under the composite. it would be too specific to this problem we're trying to solve. We want to make it generic. Guys, are we okay with this? Okay, so now you have seen both. Basically, I've just explained the composite pattern, but let's look at that anyway. Okay, I would say this slide here is very important. You know what? I can easily turn this to an exam question, right? Easily. What I would turn that into is like this. It might be to your advantage, right? I'm not sure if the other section will talk about this, right? Maybe I can insist on this question in the exam. So now, in the exam, I might say, let's consider the following design for equipments and also for furniture, right? I'll simply say, let's say for the composite equipments and for the composite furniture, I support add and children. Now, criticize the design. Okay? Exactly how we just discussed. And part 2, improve it. Huh? That's how you factor that out. That could be a nice exam question. Okay, any questions about this? Everybody's okay? Huh? It does. You missed last class, right? Yes, please refer to the recording. We did talk about multiple inheritance, yes. Yes, it does. Okay, multiple inheritance just make everything work at the design level. Okay, that's really important to notice. All right, so now let's, some repetition will be nice. Let's now move on to the actual composite pattern. Okay, this is the actual one. So now you can see exactly what's going to happen over here. Let me try to give you some connection about how is this diagram over here going to be related to this diagram over here, okay? You can think about what we just talked about over here. You can think about every class over here, the main, let me do it again. Okay, basically equipments, the cart, and also everything to do with equipments. Okay, I'm not including composite. Everything here is going to be the equipments, the manufacturing cluster. Okay, you can see this is outside the manufacturing cluster. You can imagine that you can solve as many other similar problems as you want. I can have another cluster over here. Maybe I can make it furniture. And then somehow the composite furniture over there is going to also be a subclass of that, right? As we draw. Okay, just sketch very quickly to you. Okay, so now pretty much like how we talk about. So a very common confusion for the composite pattern is as follows. There are 2 arrows that could be a little bit confusing. Let me show it to you. Number 1 is a client-supplier relationship over here. Okay. Number 2 is the inheritance relationship over here. The green and the pink, both are necessary. Okay. So now let's talk about the pink one. The pink one we just talked about in the previous slide, right? It's really necessary because you want to make sure only the composite equipment's descendants can support the children and the add features. So the pink one is really important, that's inheritance. But now you also want to make sure you understand this particular green arrow over here, which is children, right? Because as soon as you say the composite equipment is going to inherit from composite, so that means you're going to have a list of children over here. That's why you got this particular client supplier over here. Okay, that was a little bit less obvious to the pattern. Okay, guys, are we okay? Are you comfortable with both arrows? Okay, so now let's revisit one example here. When I talk about the first design, which was not so good, right? I said the first design was not so good because if I say cart, which is basic, dot add another disk, it will be allowed, but conceptually it should not be allowed. That's why this is not a good design. Now in the new composite pattern, would this be allowed anymore? It should not be, right? But let's double check, okay? So now if I say, okay, you still can say chassis, which is composite, that's not a problem because we do support children and add for composite. I want you to look at this line particularly, okay? This line here. Okay, this line here. You can see now the context object over here is D. D is of type disk, okay? Disk drive, actually. Disk drive over here. Now, when I say D.add, is it still going to compile? No, right? Because you can see this drive is inheriting from equipment, but now all the tree-related features have been factored out to the composite, okay? So this will not compile anymore. So does not even compile. Okay, that's the composite design. Okay. Again, I think to really help you make a transition from the first design to the second one, you really want to understand the discussion for this particular one. Why we have to make composite a separate generic class? It's really for reusability, for the composite actions. Okay? So whenever you're trying to solve similar problems, you can always make use of this composite without duplicating the code. Okay? Any question about composite design before we see a little bit runtime behavior? Okay? The runtime behavior is going to be a little bit complicated, but I'll choose some simple example to show you. Okay? Yes? The green arrow? Sure.
Why is equipment supplying children if it doesn't have it?
No, it's the other way. Good. You know what? Let me just do the following. The green arrow is typically could be a little bit confusing. Okay? Let me try to redraw this a little bit, part of it. So over here, we got our equipment over here, which is deferred, and then under which, let's say we got a card. And then we also, under which, we also got another class over here, which is called the composite equipments. Okay, let's say just do the chassis for one example. We also know that we have another class over here called composite, which is generic, let's say T, okay? And then that means we got add over here, which is going to add something of type T. And also children, which is going to be a list of T. Okay, let's maybe clarify first. Okay, so now let's put inheritance, okay? Your question was, why did we have to draw a client supply over here? The reason is as follows. Think about what's being inherited to the composite equipments. If you think about it, it's going to be add and children, right? Because it's a subclass. Specifically, if I put children over here, in this particular case, as we see the code, the way you're going to define the composite equipment is going to be like this. You would say class composite equipments is going to inherit the composite. However, I gotta instantiate the T, right? In this case, that should be instantiated into equipments, right? Okay, that's a little bit more programming. Okay, so that means children in this case is going to be a list of equipments, like that. So the composite equipment itself is not generic, because it's using some generic class by instantiating the T into equipments in this particular cluster. Okay, let me just say one more thing before you ask more. So now you can see that for this since in the composite equipments, we are having let's say attributes over here. So now that means we're using two classes as a supplier. This is a supplier number one. We're using a list. So you can think about a list is one of our suppliers. And also we're using equipments. That's also, it's element type. That's also a supplier, right? That's also supplier. So now for your design diagram, you don't necessarily put all the suppliers into the diagram. You only choose the important one. In this case, supplier is going to be equipments. So now we're going to decide which direction to go. You point to the supplier. Okay, that is why you say over here. Okay, you would say children over here. And then you would say a list of whatever type the supplier is. Maybe to answer your question, I hope.
Yeah, I was just confused why the arrow is pointing.
Yeah, you always point to the supplier.
So it's pointing there because it's getting equipment.
Correct. Yeah, specifically, you can see that the little bit trick over here. You can see since we inherit from composite of generic type T, but now because in this particular scenario, we are instantiating T to be equipments. That's why equipments is one of the supplier. That's why. You'll be the same case for add, yes. But you don't. But again, whatever feature you want to show in your diagram is completely up to you, up to your judgment. But I think that in this case, it's reasonable to show children. Right?
Is it possible or is it okay if the generic type changes the composite equipment of different treatment?
So you're saying, okay, I see what you mean. You're saying that can change this class over here, you mean this class over here, right? You, oh, you mean over here? You mean the T over here?
Yeah, the T, you change it to equipment, right?
Yes.
And we change it to composite equipment.
Composite. Okay, so you're saying, okay, we got a class over here. Composite equipment, you want to make it generic? Or?
No, the composite generic. Right now, the generic type is equipment, right?
Mm-hmm.
Can you change it to composite equipment instead?
But equipment itself is not generic. So when you inherit composite equipments, tell me what to change. I'm a little bit lost. What do you want to change? Which class?
Children list composite equipment.
Change the composite equipment to what?
No, children list composite equipment.
The children list? You mean over here?
Yeah.
Oh, you're saying composite equipment, right? Ah, now I see. Okay, sorry. Yeah.
Is it possible or is it okay?
Oh, well, you're sure you can do whatever you like as long as, well, first of all, you can do whatever you like as long as number one, it compiles. That's the minimum requirements, right? If it doesn't compile, well, we don't discuss further. Okay. Number two, even if it compiles, is it appropriate? I like this question. Yes, now I understood. Okay. I like that. So now, to really make it very worth you noting, I'm going to copy this guy here. Okay. So now I want to create a new page and make it absolutely clear to everybody. Okay, basically what you're asking is this. Okay, let me just wipe it out quickly. Okay, you're basically asking the following. It's a very good question. You're basically asking, rather than list of equipments, I'm going to say list of composite equipments, right? Good. Okay, if you simply say that, it is going to compile. However, is it right? Okay, I can tell you that it's going to compile. However, is it appropriate or not? Let me give you a little bit of hints. If we follow this design, is it going to constrain any kind of a system that we want to build, but we cannot build it anymore? For example, over here, are we able to build a system like this? Okay, some of you knock your head, right? Can you tell me which part I cannot build anymore? Yeah, exactly. You can see that. Remember, you simply say every child in the children must be a composite equipment. That means every child, for example, for the cabinets must be a composite equipment. Is power supply a composite equipment? No, it's not. Right? So now let me make it more precise for you. Okay? So now imagine that if I simply got, let's say, let me just make it corresponding to this example here. I got PS, which is power supply, and also I got another one, let's say cabinets. Okay? Let's say C. It's going to be cabinets. So now when I say C dot add PS, now okay, you can see why reviewing inheritance polymorphism is so important before the reading, well, before and after the reading week. So now, is this going to compile? Okay, so now how do we tell? I know it's not going to compile, but why not, right? Okay, look at what's the static type for the input arguments. Power supply, right? And now, what is the static type that's being expected? Composite equipments. Is power supply a descendant class of composite equipments? No, it's not. Not descendants. Because power supply would just be a subclass under equipments directly. It's a basic component, right? I tell you what, this can also easily be turned into exam questions as well. So now we got 2 questions for composite pattern, which is nice. Okay? Well, they're easy, right? Hopefully that's not too bad, right? Guys, okay, seriously, are you following? Okay? Okay, good. Oh, well, I tell you what, what's happening over here, this new design, by changing list of equipment to list of composite equipment, it will still work for some system, but will constrain some other system which we want to build, but we cannot build anymore.
So the one that is basically inherited from the working one.
Yeah, actually, you know what? It's going to be very bad. For this one here, you can never terminate a tree at a leaf level. You can never add a base case to the composite. Okay, that's a problem. Okay, good. So now, any other questions? Actually, I like both questions you guys presented today, right? I think it's really worth spending time on that. That's really good. Okay, after this, I would like to go over a little bit of code to actually show you how things will work at runtime, because this will give you a little bit warm-up for visitor, okay, which we'll talk about a little bit today, okay? Maybe not the whole design. Visitor is actually complicated. It will take a whole class for sure. Okay, what I would like to, I'll come to this point a little bit later, after we see the runtime. Okay, that's the first design, which is not good. And then we talk about the flaw of the design, okay, but we got much more discussion than what's on the slides. So you can refer to the iPad notes later. Okay, that's a composite design, okay. So now what I would like to do is to show you a little bit of code, okay. How do we define the composite pattern, okay, if you want to apply that for your projects for whatever reason. So now we're going to say equipment itself is going to be deferred. And then let's say we got name of the equipment and also the price of the equipment. So there's something I call uniform access principle. Usually I cover uniform access principle before I talk about the pattern here, but we're kind of running out of time. So let me explain very briefly to you. I'll cover this uniform access principle maybe a little bit later. Okay? It's very easy to understand. Basically, from the client's point of view, it doesn't really matter whether you implement a feature as a query or as an attribute. From the client's point of view, they always just call the feature directly. Okay? We're going to see that. Okay? As, or you don't have to be bothered by uniform access principle, the name, just yet. Okay, let's say we got the card over here, which is the equipment directly under. You can see the card. Let me just go back there. You can see card is directly under equipment. And then we'll simply say make a equipment over here. So now the price can be assigned, which means price at this level is just an attribute. Okay, just an attribute. So that's a basic component, which means every basic component has a fixed price. What about composite? That's where the complication comes in. Can the price for a composite equipment be an attribute? Presumably yes, but it's kind of hard to keep track of, which means every time you add a new thing into the composite, you want to update the price, right? It'd be maybe easier to calculate on demand as a query. Good. So now we want to see how things, I'll show you the code very quickly, and then we'll see how polymorphism and dynamic binding is going to work at the runtime. It's really important to follow that. Okay, let's see this. So now let's say, also we got a deferred class, composite, generic type. Again, T is just one generic parameter. You can use G or H, whatever you like. Composite, we can be a list or a linked list. Okay? Children, and also we got add. In which case, I'll simply say children.extend. Okay, so now I say polymorphism. Okay, can anybody tell me what do I really mean by polymorphism here? Basically, I'm claiming that children at the runtime for any composite is going to be a polymorphic list. What does that really mean? Exactly. Whatever T is instantiated into, it can be furniture, it can be equipment. We can add any object whose static type is a descendant, not just child. It's a descendant of that class. Okay? That's how we do that's how we have polymorphic collection. Okay? We'll get there. Okay, that's about the composite. And then, how do you make it iterable? You just did it, right? Last Friday. Maybe? I don't know. Oh, let's not talk about it. Oh, guys, you know what? I'm really impressed by the raw marks of all of you. The raw marks, like the initial grading. Don't worry, the T is looking into your submission. Don't panic. We're going to do something about it. Yeah. If there's something can be done to your submission, right? But don't panic. We're going to tell you the grades for the lab test a little bit later. We are hoping, well, I tell you what, since we are trying to handle the submission for both sections, and one is more impressive than the other, and then somehow it can take some time. May not be this week, may not be. But you'd rather we do something, you'd rather we look into it rather than not, right? Yeah. Okay, don't worry, we'll handle that fairly. Okay. Okay, let's go back to composite. Okay. So now for composite equipments over here, we're gonna get inherits, and then, so here you can see that's the multiple inheritance. Inherits equipments, inherits composite, and now we say that should be equipments, right? Okay, so now, you want, again, from our previous discussion, you want to know why not. We simply say composite over here, instantiating this to be composite equipments, right? We say that there'll be two constraining, right? And we also got things like we can make a composite equipment by just initializing the children list to be empty, okay? It's a linked list. And now, how do we calculate the price? I can tell you that our attribute might work, but it will not be so easy to maintain. So let's say we do the as a query. How would you define this query here? So when you say, okay, you basically say we're going to maybe go across the children, and for each children the item, we want to see whether that's composite or basic. Yeah. Sure. Okay. Basically, you're saying that under the loop, you're going to do some if conditional check to say if the current elements is an instance of equipment, we are done. Just return the price. Otherwise, we might have to go deeper. Recursively, right? That might be okay. That might be okay. I'll get to you in just a moment, yeah. Basically, what you're saying, let me sketch very quickly before I show you the code. It's really important because I want to make sure you don't do that in your projects. Okay, let's see, okay? All right, so let's go back here. Let me just go very quickly here. Basically, what you're saying is, let's talk about the composite equipments. You're going to say across the children as, let's say, C. And then I would say loop, for example, something like that. And then I'll simply say if C is if let me say this, if attached to equipments C the item, then I'm going to do something, okay? Otherwise, it will be composite, right? As you said, I agree. And then you will do something else, maybe make a recursive call, okay? That might work. However, it's unnecessarily complicated. Okay. Ken, did you want to say something?
I was just going to say, you just go across the children, like price.
Aha, exactly. Okay, so basically we're talking about this simplifiable. Okay, so basically the whole thing over here can be simplified to just a single line. C dot item dot price. Remember, price is a common property at the equipment level, which means both the base and the composite equipment will have a price. So now, how is dynamic binding is going to come into play? Quickly, I'll show you the code. I'm just sketching idea a little bit to give you intuition.
Because it's going to call the price feature from whatever the dynamic type is.
Aha, exactly. So now you can see that over here, C the item statically is just going to be an equipment, right? Because children has the type equipment, right? As we said before, the children, the correct design should be just equipment. So now that's a static type, which is guaranteed to have the price. Now dynamically, what can be, because it's polymorphic, it can either be composite or it can be basic. Right? So that means there are two different versions of the price we can call. So now you can see, somehow I said this will be unnecessary because this will be done by the runtime execution engine anyway. You're just doing the job for them. Okay, that's not necessary. Okay, that's really the beauty about dynamic binding because you really don't need any if statement to check the instance off. If you realize you have to use so many instance of checks, something wrong with your design.
Is there any point to making
Oh, you mean, oh, I see what you mean. You're saying that, sure, you're basically what you're asking was, okay, that's good. Yeah, we should really handle every design question, as many as possible, okay? So let's say we got equipments over here, okay? So we've still got our composite equipments, okay? Under which, let's say we got chassis, for example. Okay, this is another inheritance over here for the composite, okay, which is generic. Okay, you're basically asking the following. Can we just create an intermediate class over here that is called basic components? And then have this inherit from here, and then let's say cart, for example. That's basically what you're asking, right? I would say it depends. Okay, it depends in the following sense. Anybody want to answer before I give my answer?
If there's common features that you want all the base components to have, then maybe it makes sense to do that.
Aha, exactly. Exactly right. Okay, let me repeat, that's exactly right. Okay, here's the answer. The answer is you will only want this pink intermediate class to be added if the following holds. That means you have some feature, let's say F1, that you want to put, that you want it to only belong to the basic components only. Because if you actually put it over here, it will be inherited to the composite as well, but you don't want it to happen. If that's the case, you want it to be just an intermediate class, yes. It's too bad. If you guys did a project with me last fall, you would have something like this for the composite pattern. But for the battleship, I'm not sure if you want this. Anyway, depends on the cases. Okay. Okay. Actually, are we okay with this? That's another good question. Actually, very good. Yeah. Yes. You mean over here? What do you mean to check the dynamic time? No, actually, I don't think you need any cast over here. Yeah. Mm-hmm. Okay, that's good. So now let's go to see a little bit more code and then try to chase the program. And then at least we can talk. I think tracing the program will take a little bit of time. Okay. Okay, that's exactly what's going to happen here. You can see there's no instance of check. We simply say result. Well, it's going to be a query. Result is just going to be incremented by cursor.item statically just equipments. But dynamically, it can either be base or composite. Right? We're going to see that. That's dynamic binding. Okay. Now, let's trace a simple example. So you want to know two things. Number one, how do you build a tree structure at the runtime? Number two, once you get a tree structure, how do you know it works? Okay. You want to know both. Okay. And both will be required for the visitor pattern. Okay. We'll get there. Okay. So now what I would like to do is I want to do a little bit test. Okay. I think I do have that on the iPad over here. Okay, again, this slide over here, well, this page over here, just for your information. So I just put the code and also design all together. We got equipments over here. We got basic equipments, and also we got composite, and also we got composite equipments. And you can see the multiple inheritance over here. Okay, just put everything together. Okay, but we have gone through the details already. So now what I would like to do, I want to trace the program together with you. Okay, let's try. I put all the classes that you should know in order to trace. Before that, let me just make this a little bit larger over here. Let's focus on this. Basically, we declare so many variables: car, drive, cabinets, chassis, bus, like that. Okay. For your information, cabinets, chassis, and bus, they are composite. Okay, for your information. And then, let's say we create a cart, we created this drive, because they are, because the car and this drive, they are basic. So we can have some description over here, and also we can give a unit price for the base component. We can give them right away because they are simply attributes. On the other hand, when I go to the composite equipments, let's say the bus, the chassis, and also the cabinets, you can see I can only give a description, but I cannot really give a unit price. I cannot give you unit price for any chassis because I don't know how many equipments you actually contain. It could be a lot, it could be none, right? Good. So now let's try to trace the program together. Okay. Let me try to bring you. I already drew some diagram over there. I'll try to see if I can just bring you up to speed quickly. First of all, I got the blue one. Let me be consistent with the color here. Okay. So now when I try to, okay, let's say this. You can see I have a cabinets object over here. I have a chassis object over here. I also have a bus object over here. You can see for every one of them, they simply got a field called children, I should say C, which is going to be like an array over here, right? Eventually, they will be extended with different equipments, okay? And also we got drive, we got car. They're simply basic, which means they have no children field. So they got unit price 500 versus 200, right? That's what we have. So now, let me undo this. So at least you're comfortable with the diagram so far. No connection has been drawn whatsoever. We're going to see how the connection can be drawn. So they become a tree structure, not a graph. There's no cycle, okay? Let's see the first one. The first one is going to be blue. That's exactly what's going to happen. I say the bus is going to add the car as a child, right? So the bus is over here. Is going to add the cart over here as a child. So that means it's going to link from over here to over here, right? One important fact to know, every time we do OOP, we're only copying addresses, right? Doing a reference copy, right? It's efficient. Okay, number two, when we got these two oranges over here, chassis.add, bus and drive. So you can see the chassis is over here, and then we're going to add the bus and the drive, which means now chassis is going to point to the bus as the first child, right? And also chassis is going to point to the drive over here as the second child. Are you comfortable with these two? Basically these two, especially the first one. A composite can simply add another composite as its child. You can see over here, the bus over here is simply just a composite. And for the chassis, I'm adding the bus itself as the first child, right? It's simply pointing to the bus over here. Okay, we are gradually building the tree structure. Guys, are we okay? Yes.
This implies that like the composite equipment don't have the price themselves.
Correct. Well, because we can define the price for composite equipment simply means the aggregates of the prices from your children, which can be recursive somehow. You can see exactly how the tree can be arbitrarily deep and complicated, right?
Wait, then like say the name of chassis is just the name for the.
Yeah, just the name for that particular chassis. Maybe it's like a label you put on the chassis, right? Yeah, like the chassis 1 in the person lab.
Itself doesn't cost anything.
Let's assume that. You might have some maybe base price for the chassis hardware itself, adding on top of all the equipment. That can be extended, but that's not a complicated matter. Yeah. Okay, that's good. And let's do one more to finish the tree. Okay, so now over here, the last one, cabinets.add chassis, which means for the cabinets over here, it's going to have the first child pointing to the chassis. One of the past exam questions was to ask you to write the code that is going to build a tree like that. Okay, are you okay with that? No? Okay, maybe practice, okay? You know, we got another chance to practice when we talk about visitor. How about that, okay? What I'm trying to say is there are two things you want to know very well. Number one, given the types for all the equipments and composite equipments, you want to be able to build a tree like that. Number two, which we're going to do now, is to say how the tree can be recursively traversed, okay? It's going to be a little bit like a post-order traversal. Does it make sense to you, post-order? Visit all the children before the current. Something like that, a little bit like that, okay? If that makes sense to you. Okay, so now let's try. So now if I look at the test case over here, you can see there's only a single line for you as a client to write. You only have to write, let me use, which color have I used? Maybe red. Cabinets.price. That's it. You can see cabinets is the top level objects. And when I say cabinet.price, eventually it's going to tell me it's 700, which makes sense. It's going to be eventually add up 500 and 200 together, eventually. But how is it going to do that? Let's figure out. Okay, so now I want to execute this line specifically. Just this line, very quickly. When we do that, cabinets.price, okay, let me just do it again over here. cabinets dot price. Now I have a question for you. Apparently you can see there is two versions of the price. Under the equipment over here, you can see any basic components. We have the price being an attribute, for example, 500 and 200, right? That's the first version. Second version is the price that's implemented as a query, right? So now, when I say cabinets.price, which version am I calling? Second one, right? Hopefully you can see that, right? Because dynamic type over here is cabinets, which means it's going to call the composite equipment version, okay? So now we're going to we're going to execute exactly this price over here. And now tell me something. How many iterations are we going to have? According to the diagram, how many? How many iterations? One. You cannot see two, right? Just one, right? Because depending on how many children you have for that top level cabinets, you can see there's only one single child over here. Okay? So that means over here for the very first time, cursor.item over here for the very first time is going to be this particular chassis. Okay, I'll write it as a note. Chassis. Okay, so now there's only one iteration to go, but we don't terminate from there because chassis.price is going to go down to the tree, right? So now let me use a different color over here. That means I'm now going to say, so calling cabinet.price is going to in turn trigger chassis.price. So now if I do chassis.price, again, the same question for you. Which version of price I'm going to do? Version 1 or version 2? Version 2, right? Good. Okay. I'm going to call in this second version over here for the second time. So now if I do, how many iterations do I have? 2. Very good. And the first iteration is simply the first iteration, I'll say. The first iteration is going to go into this particular bus, right? It's going to be bus, the cursor, the item will just be bus.price. Is it going to terminate over there? We're going to go further. It's going to go further, right? So that means after this one here, let me just write it down. And this one here, first of all, is going to turn out to be bus.price. Okay? Bus is over here, which is also composite, right? And now bus.price will in turn, let me go a little bit deep, more directly. Bus.price is going to have only one iteration for the child. Eventually, it's going to get card.price. Agree? Okay? It's going to be card.price. In this is terminating, so that's going to give us 200. That's only the first child, right? For the chassis. And then when we go to the second child over here, which is going to be in pink, the second child for chassis is going to be drive, right? Second child, okay? It's going to be drive.price. And now, which version are we calling? That's right. That's terminating case, exactly. That one there, which is going to be 500, which means eventually you will actually get 200 from here plus 500 over here. You get 700. It's a very simple illustration, but you really want to see we are only calling as a client's cabinets.price, but because the way we set up the tree, this composite pattern is recursive. Even though you don't see the recursion per se from the client's usage, but under the hood it's really triggering some recursive traversal of the tree. Okay? That's the interesting bit for the pattern. The burden is more on the supplier side. For the client, it's very easy to use. Okay? And the recursion actually comes from dynamic binding. Okay? That's something you haven't seen so far, right? I hope. Then that means you're learning something new. Okay? Okay, guys, any question for composite pattern here, the runtime behavior? Okay? So we talk about designs, we talk about runtime behavior. Let's go over maybe one more slide. I think, okay, that will be the visitor. Okay, we still got 20 minutes. That's good. So what I would do is, go over one more slide with you. So that's about the test cases I just went through. Okay, that's good. As I promised, I'm going to go over one more slide with you, which now hopefully will make more sense. Okay, so now when I introduce the composite pattern, Okay, sorry. Let me just see where that slide is. Here we go. Okay, so now let's make a quick summary to the composite pattern. Now that we understand both the static design and dynamic runtime. So now the composite pattern is really as follows. So at the design level, we are really trying to categorize your components into basic versus recursive. It can be either furniture or it can be equipment or anything, right? For the programming part, you basically talk about a tree structure that you want to build, exactly how we did it. And also when you do the traversal, it's going to be recursive because the tree is recursive. At the runtime, okay? Uniformly here's really important. From the client's point of view, let me show you one more thing. From the client's point of view, you can see, given that this is what the clients have constructed so far, right? The clients might say, I want to simply say, I want to check the cabinets.price. But what if the clients want to check the cart, the price? They will do the same thing. They will also do cart.price. You can see the feature that's being called is just the same. It's just that the context object will be different. That's why that's what I mean by uniform. Okay? When the client wants to figure out the price, it doesn't matter what the kind of equipment you have. You just say something.price. Okay? Dynamic binding is going to handle the rest. Okay? And then polymorphism, because we got polymorphic children, right? It can be each child can either be basic or composite. Okay? Dynamic binding, as we explained, for the price. Okay, and then now given equipments over here, you can actually E.price may refer to a basic components dynamically, or you might refer to the composite equipment, which will trigger some recursive traversal. Okay, so this slide actually, when you study the exam for the composite pattern, start with these slides. Okay, to see if everything makes sense to you, and think about it. Okay. Any question for composite before I move on to visitor, which is completely related? Questions? Sure. Uniformly, let me read it out first. At the runtime, allow clients to treat base objects and recursive components uniformly, in the sense that for the clients, all they have to know is to use a dot notation, dot price, basically. So now if I go back to that iPad, this page over here, you can see from the client's point of view, they simply construct some tree structure over here, right? So now they have the freedom as to which components to inquire the price about. I can ask about the price for this particular cabinets overall. I can also ask about what about the sub price for this particular chassis, and what about the price for this particular drive. Doesn't matter. All you got to say is something.price. That's what I meant by uniform. Because the reason that it is uniform was because price was declared at the equipment's level. Okay? If I look at the design diagram very quickly, if you go back to the very first diagram, you can see equipment here is going to have the common property, which is price. That's why. Okay? Put all the common property here in the equipment's class. Of course, as we said before, if you do want to introduce an intermediate class called basic equipments, that's also fine. But that means any feature that's there should only belong to basic equipments, but not the composite. Okay? You can refer to the discussion again. Okay, so that's good. So what I would like to do now is to talk about visitor. And I will only talk about the problem we're trying to solve for the visitor. Okay, first of all. Okay, let's go over a little bit slides and have some discussion over here. Okay. Motivating problem. Okay. Basically, we're going to see a very similar problem over here to begin with. Okay, you can tell me if you can apply what we just learned to this problem over here. Let's talk about language problem. Let's say if you want to do some natural language processing, that means you want to parse the language, right? How do you parse the language? You want to have some grammatical structure. And once you parse the language, how you can apply a semantic operation to the language. That's something we can solve. Okay. Now let's make it simple. Of course, we don't do that, in the lecture. That'll be too big. Let's say based on the composite pattern, so that'll be applicable. Let's say we want to support expressions, simple expression. It can either be a number let's say only positive number. That's not complicated matter. It can be 341, it can be 2, and then, or it could be an addition of numbers. So now, based on what you learned previously, what should be the design? First of all, how many classes? Okay, I do have the solution on the pad, but I don't want to show it to you. Okay, I want to draw it together with you. That will be a practice. Okay, you can. Okay, let me say this. You basically got 341, 2, also 341 plus 2, or even more. It can be 341 plus 2 plus maybe, let's say, 461 plus 3, right? As complicated as you like a tree structure. How do we model that? Using composite pattern. If this appears in the exam, part A, draw the composite pattern for this, part A. Part B, write the code to instantiate some runtime objects that will represent, for example, 341 plus 2. Right? Let's try that. Yes, design first. Okay? Okay, deferred class you meant. Okay? That's okay. Deferred class called expression. I like that. Sure. One moment. Yeah, let me. Good. What should be in expression though? Any feature here or empty class? Value. Okay. Sure. Let's say. Okay. Out. Yeah, I agree. Can be the string representation. I agree. Okay. Value could be, let's say, integer. Let's keep it simple. Integer. Out could be string. Good. Let me move this a little bit to the center over here. Okay. Any other class? That's one class, expression. So far, it's not very useful. Nothing can be instantiated in the runtime, right? So far. Yes, go ahead. Number class, like a constant. How about that? Okay. I agree. For example, 341 is a constant. Okay. So what I would do is, let's say, directly under this, I agree, right? I assume, plus constant. You can think about values like a price, right, for the equipments. What else? Operator, sure. You mean under expression? Operator or operation? Maybe binary operation, how about that? Oh, you know what? It's interesting. How about we say operation for now, and then I will challenge you for that. That's okay. You know, actually, I think we might need 3 more. Yeah. Yeah, you know, it's okay. Let's go one by one, okay? Okay, so we have, let's say, operation, okay? Okay, and then, okay, let's put operation over here, okay? And then what else? 2 more classes inherit from. Okay, what class? Addition, sure. Under what? Addition. Combination. But you can see, oh, well, actually, you know what? It's a good question. To really achieve something like this, oh, of course, before I talk about it, of course, don't forget, you also need to have the composite over here, right? That's got to be reusable, right? Don't forget the composite over there. If it didn't tell you got that available, you got to define that, okay? So that means it's also going to inherit from there. Don't forget. Okay, now the question is, do you think as is going to be enough? Of course, we got at over here. We also got children. Oh yeah. Okay. You talk about renaming, right? Are you just talking about to? Oh, you're saying something like this. You're trying to say, rather than over here, something like this, you're saying another class.
No. Operation still will inherit from expression.
Sure.
And
Create another one. Call what?
another class and inherit from expression.
For expression?
Yeah. And you can name this class composite expression.
Composite.
And then there's the inheritance from operation to composite. Yeah. And then the inheritance from composite expression.
So you're saying over here, this is going to inherit from there?
No. From composite expression, it inherits the composite.
Like that? That's it? I have a question for you. Okay. Oh, anybody got any question for him? Is it going to work?
Well, no.
Let me ask you this. It's going to compile, but the problem is, how do you add children to addition? You see what's going on here? You can see the composite expression over here is going to inherit add and children. However, addition over here is only going to inherit from operation, which does not inherit from there. Right? That's a problem. Okay? So it's not being supported. Okay? Okay, that's not good. So now let me undo. Okay, like that. I think that's quite reasonable, right? I do have a question for you. Okay? We agree that for every addition is a binary operation. Agree? Which means, conceptually, if I got 2 plus 3 and 3, it doesn't make sense, right? It got to be exactly 2 operands for the addition, right? At the moment, can we violate that conceptual agreement there? Why is that? Well, the problem is, let's see this. If I have something like this, let's say I got addition over here, let's say ADD of type addition. Okay, now I can say add, and let's say also constant 1, constant 2, constant 3. It's simply just going to be constant. And let's say we already create C1, let's say we already created them already, let's say, okay? I can say addition is going to have C1 as a child. Addition is also going to have C2 as a child. Addition is also going to have C3 as a child. That's not right. Because addition is supposed to be a binary operation. It should be exactly 2 children. Right? Exactly 2. That's the problem. Now, how can we solve that problem there? How can we somehow constrain to say for addition, it should be exactly just 2 children?
You could put it in invariant and an operation.
Aha. Now I got another question for you. What if I have, let's say I want to support also, let's say the negative operation. Let's say negative, like change the sign, right? You see where I'm going, right? Let's say operation under which I simply got over here, let's say negates. Let's say negative. In that case, if I simply got an invariance over here to say children dot count is equal to 2, is it okay? No, because it's going to violate negative, right? So now, let me draw a final picture for you, okay? I just want to give you an idea about how you can design, as complicated as you might think necessary, okay? The final picture looks like this, okay? Let me wipe it out quickly, okay? So what you may want to have is something like this, okay? So now under expression, you might have operation still, that's okay. That is simply just going to inherit from composite. So far, so good, okay? However, under operation, we got different kinds of operation. It can be unary, it can be binary, it can even be ternary. Okay? Let's say unary or binary, okay? Under operation, we have basically unary operation. Under also we got binary operation. Okay, and then under which, for this one here we got negative. Under this we got addition. And now we can put invariants separately. For example, over here, for a binary operation, we're going to put invariants to say children dot count is simply equal to 2. And over here, we're going to say invariant for unary operation, invariants over here, children dot count is equal to 1, right? Different invariants, right? You can see the design over here. We're going to talk a little bit more about contracts in the context of inheritance, maybe after the design pattern, but that's okay. At least you get an intuition, okay? The advantage of this is you can still, that means if you got anything that's neither unary nor binary, you can still put them as a subclass directly under, in which case you have no constraint whatsoever on the size of the children. That's still possible, right? So adding, every time you add, you're introducing a class in the hierarchy, make sure you know why you want to do that, right? There's got to be a reason. Okay, good. So now we got about a few minutes. Okay, I can go over a little bit more issues over here. Okay. So now that's about composite. Okay, let's say we stick to this easier one. Okay, let's say we simply got value in the expression, and also we got constant, we got addition, and now we simply for composite we just say left and right rather than children. Okay, just for simplicity. Now, so what we just said over there was just the problem for composite. Let me now move on to the motivating problem for visitor. Basically, you really want to think about composite and visitor together. Composite is part 1. Visitor is part 2. Okay? Now for part 2, let's say we have built such hierarchical structure like a tree. Now, let's say I want to support the following operation. Let's say, again, you want to do natural language processing. You want to do some little bit of operation. For example, let's say you want to say either I want to print the expression in prefix notation, or I want to print the notation in postfix notation, or I want to do a type check. Or maybe I can say I want to generate C code, generate Java code, generate assembly code. There are various operations I want to do, right? Given the same language as a source, I can have many different targets as the output. That's basically the idea. So the same tree structure from the composite, I can do many operations on the same tree. That's a motivating problem for visitor. Any suggestion? Okay, let me just go back to this particular. Oh, by the way, there's a quick. Let me skip this for now. Okay, I'm gonna go back to this when we talk about visitor. So now my question for you over here is, let me just review what we have in the diagram. So we talk about the structure of the language being the composite over here, right? This is the composite. So now this is a new problem. We want to support evaluates. For example, if we got, for example, let's say 3 plus 4, right? If we want to evaluate, it's going to give us 7. If you want to say print prefix, it's going to give us 3, 4, and then plus, right? You want to print postfix, it's going to be plus and then 3, 4. And then you want to do a type check, you might simply say true, because you can add up 2 numbers together, right? So there are the various operations we would like to support for the same structure. Any suggestion? How do we extend the design? Yes?
These operations for expression and for composite?
It's going to be, well, you can think about for the composite. Well, when I say composite, I mean the whole structure over here. How about this? The operation we want to support over here, evaluate, print, and also type check, is going to be eventually for expression, the top class, eventually. So now the question is, any suggestion to extend this design over here to support these operations? Anyone? At least we can go over one quick solution together, if we have time. Okay. Let me, anyone want to speak out before I give you one solution? Okay, how about I give you one potential solution? Well, since the operations will be supported for every expression, why don't we put it in the common ancestor? So I can simply put evaluates over here. I put print prefix, print postfix, And also I got type check. Later on, I can also say generates C code, generates assembly code, okay, something like that. This design might work, right? You just implement everything into the expression class, right? Is this a good design? Huh? What do you mean constant? Yeah. Oh, actually, you know what? That might be okay, because let's say for here, let's have a constant over here, right? How do you evaluate a constant? Just return a constant value itself. How do you evaluate print? Just print the number itself. How do you type check? Constant is automatically type correct. And for generate C code and generate assemblies, it's doable. Well, I want to know, okay, how about this? Before, maybe I can take your answer maybe next time. I want to know which design principle are we violating over here by this first design? Single choice in what sense? Basically, you're saying, okay, maybe what you meant by this. Okay, let me give you 2 minutes and then I'll be done. You can see, for example, let's say evaluates. Evaluates will have to, oh, by the way, evaluate at the expression level is deferred. Evaluates can be defined in the constant level. Evaluate can also be defined in the addition level, right? But they are not redundant copies. They're simply just customized versions for constant and addition, right? Because if you want to evaluate a constant, you simply return the value. But the way you implement addition is different. You just have to aggregate the two numbers, right? It's not really single choice principle. We talk about this principle just today. Reusability? Not quite. Starting with C. Cohesion. Why? Let's talk about it Monday. Okay, I'll see you next week.